Welcome, Algebra Kiddos, to section 11.2. Section 11.2 is all going to be about box and whiskers. We are going to go over to, I have the whiteboard ready, I have the notes ready, and the book ready as well. Remember, these videos are supposed to be the short and sweet versions of the lessons, at least as short and as sweet as I can make them while still doing good examples for you guys. But please check out announcements in Google Classroom, including our Zoom meetings, our daily online math labs. Typically going to be Monday through Thursday starting this next week. That's going to be our schedule for as long as we need to be in online school. However, I do think tomorrow I have a department chair meeting that I need to go into during your guys' normal Zoom session. So this week might be an exception. It might be Tuesday through Friday for you guys. We'll see. But check out Google Classroom, and I do have those Zoom announcements up for you guys as well. So let's go ahead and pop into section 11.2. Hopefully you guys have already turned in your 11.1 homework if all has gone well. And I'm going to go to my iPad. Hopefully this works out. 11.1, you guys did have some homework, and you also had a puzzle time. And now we're going into section 11.2. If you guys have any questions on 11.1, you also have had some test corrections that needed to be turned in that you guys were supposed to pop in to the online math labs. Just check out the times, and I have made those big and bold at the top of the Zoom announcement, the online math lab announcement in Google Classroom. So if you guys have remaining questions from 11.1 or test corrections, come find me. Here we go, section 11.2, box and whiskers. I don't know if you guys have ever seen these, depending on your previous math teachers. Some of you might have, some of you might not. Even though technically you're supposed to have seen it before, this is one of those things, the data analysis, that's super important for this life, but at the same time, as far as like a lot of the technological world, a lot of like bosses and corporations and companies are saying, we need kids that understand statistics and data analysis. That's what this chapter is, but it tends to always fall at the end of the math book. And so it's sometimes hard for teachers to get there. But all that to say, let me go ahead and show you just a few things about this box and whisker plot before we go look at an example about how it was made. And before we start trying to make our own as far as examples. Remember, you're supposed to be taking notes. So hopefully you guys are writing down a few of these things, and we'll also fill in some terms like we've done before also. So box and whisker plot. First of all, why is it called a whisker plot? Well, whiskers, what have whiskers? Dogs, cats, other animals, whiskers, check it. Maybe it makes sense why this part and this part would be called the whisker. They're the little whiskers that go out from the box that's in the middle. Box and whisker plot. There you go, there's the name. So going along with that, let me go ahead and maybe make this a little bit clearer. So we have our whiskers going out. Now, sometimes these whiskers, sometimes the one on the right might be shorter than the one on the left, or vice versa, just kind of depending on the set of data that we have. This one looks symmetric, but we'll talk more about those words, about the symmetry and the shape of these in section 11.2b, the next video that's going to come out. Just like last time, 11.2, the whole homework is due all at once with like a puzzle time due the next day. But that means that I give 2 different videos to cut up the content and make it a little bit shorter for you guys so that you can go try the A homework and the B homework. Coming back, whiskers. Okay, so animals have the whiskers that go out. So those are the whiskers. We do have, kind of like we talked about in section 11.1, we do have the big old range that says the very lowest to the very highest. That's what's going on here as far as the least value is on the left, the greatest value is on the right. We do have the median, which we talked about in section 11.1, median. If you guys asked your parents the median of a road, remember the median of data is the middle. So if that helps you to remember the middle. Now you might be looking at this and being like, that does not look like the middle. Like this looks kind of like off to the side. Well, you'll see when we start making these exactly where these came from, but it truly is the middle number. And remember, the middle number doesn't mean the middle of the number line. It means the middle data value. So if I was to ask for, like on our last test, what the middle grade was, maybe the middle grade was something like a 78. Well, 50 is the middle of like the possible grades 0 to 100, but that wasn't the middle of how you guys scored. The middle of how you guys scored might have been something else like in the 70s or in the 60s, or maybe even in the 80s if it was a really good test. It just kind of depends. So that's maybe something to help you think of. The median is the middle, but the middle of the data, not the middle of the number line. And then we have these other 2 terms that we need to figure out. The first quartile sounds really snazzy. The third quartile sounds really snazzy, but maybe if you guys hear the word quartile, you're thinking like quarters. Quarters, 4 quarters in a dollar. If I look at this, I see there's a Q1, there's a Q2, there's a Q3. That's weird. I thought there were 4 quarters in a dollar. Let's go and go check out an example of where one of these would have come from. Starting at data and then going to the box and whisker plot. And then we'll talk a little bit about, to finish this off, how or what kinds of questions you guys might be asked. So first of all, how do we make it? Second of all, what do we do with it? Okay. So there are a couple other terms. There's the box and whisker plot up here at the top that you guys see highlighted. Quartiles, quarters, 4 quarters in a dollar. I keep on bringing that up. And then we have this 5-number summary. Let's go look at an example. Example number 1, let me try to explain what's going on. So what's going on in this example is that you've been given some data, and that's what's up here at the very, very top, this right here. They're saying it's the ages of members of a backpacking expedition in the mountains. Okay, cool. Why don't we have any like 5s or 82s? Well, 5-year-olds on a backpacking expedition might be a little crazy, same as having 82-year-olds. Not saying it's impossible, but this looks to be kind of like a upper high school, oh, barely any. There's only one 18-year-old, mostly like college, young adults sort of thing. If you look in like the 20s and like just a couple that have gotten into the 30s or into 30, and that's about the max. So it looks like a maybe college age, like at a church or something, youth group. I guess it wouldn't be youth group, but a college group. Okay, so looking at this data, they've taken this data and kind of gone down here and put this data in order. And we're kind of used to that in section 11.1. Finding the lowest one, and then as you saw me demonstrate before, kind of saying, okay, let's go ahead and get that 18, and then, okay, let's cross off that 18. What's the next highest number? Okay, 22. Oh, there are a couple of them. Let's put those in. And so what they've done is they've worked their way all the way through the data in order to put them in order, and that's what you see right down here. Now, once they put it in order, remember, median, middle, they literally took, kind of like you saw me do it before, took each of these data points and counted their way in from the ends, and then the second from the ends, the third from the ends, the fourth from the ends. I could show that if that would be kind of helpful. Maybe it would, maybe it wouldn't. But how do we get the middle? I mean, one way is to count how many we have and then cut that in half. The other way is to kind of count your way in until you get to the very, wait a minute, the middle is 2 numbers. Oh, that's okay. Remember, if it's ever 2 numbers, we take the average of the 2. Now this one's easy because they're both 25. So the average of 25, if we needed to find the median, would be just that 25, if we needed to solve it, plus 25 divided by 2. But as you guys know, 50 divided by 2 is just 25. But most of you could have guessed the median's 25. I mean, they're both 25. That's easy. You find the middle of the data, which is the median, and then you need to go ahead and start counting in the other directions to find the next middle. And what I mean by the next middle is this guy called the first quartile. If I was to take everything in this middle, in this side of the data, there's 2 different sides. According to this one, there were even data points, so I can look at kind of, once I cut it in half, what's on the right and what's on the left. On the left, I want to find the middle of that one. And if you guys count in on this one, each of our edges, or whether you realize there are 6 data points, so the middle is going to be right in between those middle 3. Maybe you can see why the first quartile, which we call Q1, is 23. Wait, first quartile, this kind of cuts this. If you notice, let me go ahead and use different highlighters so we can see. This is the first quarter of the data. There's the first 3. If I was to change highlighters, this would be the next quarter of the data, the next 3. If I was to change highlighters again, the next quarter, the next 3. And I just need one more color to finish us off. Ooh, there aren't very pretty options. Sorry, guys. Oh, green. There we go. And then the last quarter for the last 3. So literally, quartiles are cutting into fourths. So the first fourth, second fourth, third fourth, fourth fourth. This is getting a little bit messy, so let me go ahead and try to get some of this, or all of this, I should say, all of this extra work off. Let me get back to my highlighters real fast so we can see each of these. So we have the last quarter, and then we have the next quarter, which I think I had that pink being the next one. Then we had the next quarter data. Now it depends on how many data points you have as to what those quarters are, but there are 12 total data points in this set of data. So then we can say 1/4 is by 3s. So 3 and 3 and 3. And if you notice, what's going on in between each of these is we do have this median in the very middle. In this very middle, we have what's called the third quartile. And then in this middle, we have the the first quartile. And each of these, remember, if it's the same number like 25 and 25, we just get to use it. But if it's something like 28 and 30, we'll find the average, which is 29, and 22 and 24, the average, which is 23. Okay, so with all of those numbers, now that we have them, we take them down to a number line. And we don't have to have the number line go with like negatives and zero. If you notice, this number line starts at 18, that's fine. Goes to 30, that's fine. That's all we need in our data. 18 is the lowest, 30 is the highest. And what they do is they've taken each of those, what we call a 5-number summary, each of those 5 important numbers. Let me remind you of what those are. Those 5 numbers are the least value, there's 1, the first quartile, 2, median, 3, third quartile, 4, greatest value, 5. And so they've marked that least value and that greatest value, that first quartile number of 23, that second quartile number of 29, and that middle, that median of 25. And then you have your box and whisker plot if you just know what to do. The outer edge is always a whisker from the left and from the right. Then you make a box at those 2 values, at the first quartile and the third quartile. You join them together with a box and you draw a line at wherever the median is. And then you have your box and whisker plot. Now we're going to go ahead and make our own box and whisker plot. Let's go ahead and fill in just a few things that we've seen thus far as like these terms that we've seen, okay? So box and whisker plot, what do we have? Well, box and whisker plots show the variability. Well, it shows all sorts of things. Box and whisker plots, let me get to red, show the variability, which is a snazzy word unless you realize variability, variable. Variables in math change. If something is variable, that means it isn't constant. It's not staying the same all the time. It's changing. So it shows the variability of the data set. And then we can just say using the 5-number summary. Using and technically showing, we could say the 5-number summary. Now, what is the 5-number summary? Well, that's actually one of the other terms. Let's go ahead and say what the 5-number summary is. That uses the least and the greatest. I like to put them in pairs. It kind of helps my mind think of it. The least greatest, the first and the third quartiles, and the median. Now, some of you might want to instead put this in the order that it shows up in the box whisker plot, which would technically be the least, the first quartile, the median, the third quartile, and then the greatest. There are different ways of doing those 5-number summaries, but what's cool about a box and whisker is what it shows is, as it just said, the highest and lowest it goes, and then if you could say the range or the spread of the first and third quartiles, and then it shows the middle of the data as well. Quartiles, I mean, let's just keep it basic if you guys don't mind. Quartiles are just the 4, let's put it this way, the 4 equal parts of the data. We're taking whatever numbers we have and we're cutting it into fourths. And then the interquartile range is just how far. Well, let's put it this way. Let's do Q3 minus Q1. It's also known as the spread of the box. How spread out is the box? From one edge of the box to the other edge of the box, what is that spread? From one edge of the box to the other edge of the box, what is that spread? Give me 1 second. Had a quick message come in. All right, so let's go ahead and get back to our example because we need to make an example, or at least try to solve one ourselves. And so I'm actually going to go ahead and go down to, we don't need to talk about the shapes quite yet. We've already talked about, if you guys want, you can take a picture of this screen right now. I think my face is in the middle of this. Let me kind of move it up here and off to the side if I'm recording. You guys can take a picture of this really quickly if you want, as far as what each of the pieces are that we just talked about it, but it's also in your notes as well. And as you guys see, they are calling these quartiles by Qs, Q1, Q3, Q2 being the middle, which is the median. Okay, so going and finding our examples. Here we go. Here's an extra practice example. So in this one, hours of sleep, like I don't know who, doesn't say who's sleeping, but somebody's sleeping per night, or maybe it's different people, how many hours they got on an average night. And so I have this data, 7, 9, 8, 8, 8, 6, 6, 5, 4. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 different pieces of data. And as we look at those 9 pieces of data, I'm actually going to switch us over to the whiteboard because I have it already kind of set up as far as with these pieces of data. So let me go ahead and do that really quickly. Here we go. All right. Now, if you notice, just a second ago, if you need to, scroll back in the video, but if you notice, I am actually taking those data and I have written them in numeric order. Each of those data pieces, and I've written them in numeric order. Now, as I'm writing them in numeric order, I'm also trying to think of, remember, quartiles, cutting them into fourths. I'm trying to figure out where the middle of this data is. And so if I, well, first of all, hold on. We technically can right away see the least data value, which is 4, and the greatest data value, which is 9. So I can go ahead and put a point at 9, and I can also put a point at 4 as far as the least and the greatest. So now that I have the least and the greatest, now I can go looking for my middle. But as I go looking for my middle, once again, you can just count in and say, okay, I have the ends, and let's count in to the next, and the next, and the next. Hey, 7's the middle. Or you could have also seen that we have 1, 2, 3, 4, 5, 6, 9, right? 9 different data points, and so in the very middle of those 9 would be this 5th one. Because this 5th one would have 6, 7, 8, 9, and 4, 3, 2, 1. So 7 is our very middle, so I'm going to go ahead and put a point at 7. Now we do have to figure out a couple other middles, right? Because right now I've cut this data in half, but I need to take each of these halves that I have. Remember fourths, we cut in half and then we cut in half again. So if we cut this one in half, do you guys see that 6 would be the middle of that left side as far as the data? And well, this one's a little bit easy because we only have 8s, but 8 would be the middle of the other side. And so I'm going to go ahead and put a point at 6 and put a point at my 8. Now remember, how does a box and whisker go? Well, a box and whisker, we have whiskers being on the outer ends, and then we have a box. And as we draw that box, oh, my dog is as we draw that box, we can go ahead and see our box and whisker plot. Let me go ahead and see what's going on with my pup. I'll be right back. All right, kiddos, let's go ahead and finish this off. So we made our box and whisker. Sorry, there's a little bit of a glare on it, but from that box and whisker, we can answer some questions. We're actually going to jump over to a little bit more finish of a box and whisker. And I'm also going to show you in the book how to maybe use some of the examples in order to help you do some of the wording as far as the answers. Let me shift back over really quickly to my iPad so that we can see the book itself. And as we do, here we go. Let me actually go ahead and show you. Example number 2 is going to be really helpful when you guys are trying to do this homework, because example number 2 is asking a lot of the similar questions that are being asked whenever you have a given box and whisker plot, or even sometimes if you're making your own, I think towards the end of homework, and we'll peek at homework really fast in just a second. But look at these questions, and these questions: find and interpret the range, describe the distribution, find and interpret the interquartile range. And even this, I think this is in one of the end ones, but are the data more spread out below Q1 or above Q3? These are going to be really good guides for you guys to work on A and B and C and D as far as how they answer them. And then you guys can use them and use the same wording, just kind of putting in the different numbers. We're going to kind of do that, but with a new example that I have over here that hasn't been totally answered yet. We're going to have questions that we're trying to answer and then come back here and try to use the exact same lingo or terminology in order to try to figure out what it is that we're supposed to be saying and how to say it and how to say it best. So this one has already been done for us, a box and whisker plot. And let me go ahead and just kind of color code what's going on. 8.5 is, what are we talking about? Prices in dollars of soccer balls. Let's not say 8.5, let's say 850, because that's how we would normally say money, right? So we have our 8.5 or our 850, we have our 24.5 or our 24.50. So the cheapest soccer ball was $8.50. The most expensive soccer ball was $24.50. So the very first question, letter A, is actually only asking us about this range. This range, if we were to take $24.50, and if we were to subtract $8.50, and remember, technically, we're thinking in terms of money here because it's prices of soccer balls. If we took that subtraction or we took that difference, we would end up with 16, right? But not just 16, but $16. And so if we're trying to find and interpret the range of the data, if you want, we could come over here and look at that exact same question in letter A right here. Find and interpret the range of the data. And so what they're doing is they're, once again, seeing the least, seeing the greatest, doing the subtraction, which is what we just did with our price of soccer balls. And then they go on and explain this means that the song lengths vary by, well, they were talking about songs in there. So the song lengths vary by no more than 140 seconds. So we can actually do the same thing, but in ours, we could say that interpreting the range of our data, the prices of the soccer balls vary by no more than $16. The prices of soccer balls vary by no more than $16. And so if you guys notice, I'm just taking that same terminology because that's how they used it. There are other ways of saying that. Prices of the soccer balls are no more than $16 apart. The cheapest to the most expensive was only $16. There are a few other ways of saying it, like in your own lingo or your own language, but that's one way, and it's totally fine to use how they're talking about it as far as their lingo and their terminology. But let's go on to letter B and say, okay, describe the distribution of the data. This one's a little bit harder, the distribution, because technically, in some ways, the entire box and whisker plot is showing the distribution. So if you guys notice, we have our Q1, which is our inner quartile, our first inner quartile, our first quartile number, our first quartile marker. That's our Q1. We have our 20.5 or $20.25, which is our Q3 or our third quartile marker. And then in the very middle, as we talked about before, is our median, which could be Q2. We could, I don't know why I wrote an 8. We could actually mark it with a quartile number, or we could just call it what it is. It is just the median, which is one that we've learned now for a little while, our middle number. And that's right here at $15.75. But how do we describe the distribution of the data? Well, let's go ahead and go back once again and see the terminology that in letter B, there we go, they used to show the distribution of their data. They had their Q1 being right here at 220, their Q3 at 280, their median, just reminding you of some of those vocab, right there at 260. And we already talked about how their least was 160 and their greatest was 300. So as we're looking down here at their letter B is reminding and actually just saying exactly what the quartiles are. They're saying each whisker represents 25% of the data. The box represents 50% of the data. I mean, that's what's always true in a box and whiskers. We can technically always put that statement, but then they go ahead and explain, okay, for this one, what does that mean? Well, 25%, that's that first whisker, are between 160 and 220. Oh, they're just talking about how long that is. And then they're saying 50%, okay, that's the box, right, is between 220 and 280, okay, just describing how long that is. And then 25% is between 280 and 300, so describing that. Okay, we can totally do that in our box and whisker. We just have to come over and see what the different lengths are. So as I look at the first whisker and the box, and then the third whisker, or I should say the outer whisker. This first one, if I was to subtract 850 and 1125, you guys could grab out your calculators for this step, right? We would go ahead and have, I believe, 275. To think about it there for a second. I don't have my mental mathers to help me out. Then for this box, we just have to look at the length, and that's actually what's known as the interquartile range, and we're going to be able to answer that for letter C. But then we can go ahead and do that subtraction. So 2025 minus 1125. I think that's just going to be $9, right? And then our last subtraction, or our last 25%, is going to be that 2450 minus 2025. I think that's just going to be 425. right? $4.25. Okay, so as we have that, let's go ahead and see how we're going to say this. We can say, once again, 25% of our data, just like the book did, 25% of the prices are between $8.50 and $11.25. And if we need to go back to our book really quickly, we can see between, okay. So our between are $8.50 and $11.25. We can say that then the next one, 50% of our data. I've already said prices, so I can just use the pronoun them, that's okay. 50% of them are between $11.25 and $20.25. And then 25% of them are between, and I'm just saving room because I knew I was going to run out right here, are between $20.25 and $24.50. I kind of ran out of room there at the end because my iPad screen, actually, I think I can zoom out just a little bit. There we go. There we go, and $24.50. And then the nice thing is, I mean, I went ahead and found the actual lengths of those, like what the price differences were, but to be honest, they didn't even necessarily need that for letter B. They just needed to have the ranges as far as the beginning price and the ending price of each of those data sets, as far as 25% is there on the left, 50% in the middle, and 25%. So then in letter C, when it says find and interpret the interquartile range, the nice thing is we already kind of identified it up above. It was this guy right here, that $9 from the beginning of the box to the end of the box. Just that quick subtraction. And so to show that math, we could do 2025 minus 1125 if we wanted to show where we found it, and that would just be those $9. So the beginning price to the ending price of 50% or half of the data is just $9. It's only a $9 difference. So we could go ahead and try to interpret that. If you want, you could once again go back and say, okay, wait a minute, how are they describing it in the book? Find and interpret the interquartile range. Once again, if you notice, they just did Q3 minus Q1. They had this cool little acronym for it in the sense of IQR, interquartile range, but then they found it to be 60. So the interquartile range is 60. Okay, yeah, we got that. This means that the middle half of the song lengths vary by no more than 60 seconds. So that's pretty much what we just said in the sense of the middle 50% of the prices differ by, you can use once again their language if you like, no more than $9. But I also said something to the effect of, hey, that 50% of prices are no, well, maybe I did say no more than $9 apart. There's only a $9 difference. That was the other way that I put it. There's only a $9 difference, or at most a $9 difference in the middle 50% of prices. And then that very last question that they have, I think that was the one I made red. The very last question they have is, are the data more spread out below Q1 or above Q3? Now, if you guys notice, we did already figure out how spread or how long these whiskers are, and that the left-hand one, the one on the left over here, is just 275. The one on the right is 425. So they're asking, is the data more spread out below Q1 or above Q3? Hopefully you see it, because more spread out just means longer. Which whisker is longer? And so which one is longer? Q3. So we can say that Q3 has more spread since 425 is greater than 275. Okay, so we're going to go ahead and go peek at homework really fast. That was the last example that I wanted to do with you guys today as far as 11.2. We learned how to, once again up here, we learned how this box and whisker is actually formed. And then we also learned how to kind of interpret the different data and how we can totally use the book to help us with that. So that's kind of a cool thing. Let me go ahead and, sorry, my puppy's wanting some attention. Hi, pups. Maybe another day I'll let you guys see him, but for right now, let's go ahead and go look at what the homework is going to be for tonight. Or I shouldn't say tonight. I know all the days are kind of weird with me posting this the night before, but for 11.2a. So 11.2a, you guys are going to go ahead and have, I think it's 3 through 8, and then 9, 13, and 15. So 3 through 8 is just going to be this top section that basically gives you a whisker plot, which you should be like, oh, thank goodness, I don't have to make it myself. This top whisker plot right here is showing you or having you interpret the data as far as what's going on. And so you're using the one that you're given and you're just kind of labeling who's the least, who's the greatest, who's the first quartile, who's the third, who's the median, what's the range. So you're solving for some stuff there. Then I just give you, I think, just one where you have to fully take the numbers and, well, I guess number 13 is kind of one also, but where you're going to make the box and whisker plot. The nice thing is you don't even need to interpret it though. No questions, no extra data analysis, just make it. But remember, quick word to the wise, you got to get them in order. The nice thing about number 13, the next one you guys are jumping down here, number 13, okay, it's given to you kind of weird. It's given to you in a way that you might not remember or you might not have seen before. It's actually called a stem and leaf plot. In that you have like these stem numbers of 0, 1, and 2, and 3, and 4. These are stems, then you have like these leaves that are sprouting up. Anyway, it's kind of a weird name, I know. But with this guy, you can actually find the numbers that are in this just by kind of realizing how many dots there are. As far as in this data that you're trying to figure out how many hours students spent studying an exam, you have 2 different kids that both studied 0 hours. You have 4 different kids that studied 1 hour. You have 1, 2, 3, 4, 5, 6 different kids that studied 2, 3 different kids that studied 3, 2 different kids that studied 4, 2 different kids that studied 5, 1 kid that studied 7. So this might seem kind of weird to you unless you just realize all you have to do is actually just write out these data points of 0, 0, 1, 1, 1, 1. You have a lot of 2s, 2, 2, 2, 2, 2, 2, is that right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I believe that's right. 3, 3, 3. Now I know it's a little bit annoying, but the nice thing is if you guys just write it in the order that you see, you're totally going to have them in order. So that's the nice thing in the sense that they already did it in the numerical order. They just wrote it in a weird way that we're going to go ahead and use. But go ahead and write those data points out and then use them to make your box and whisker. And then I think you guys only have one other problem, and that one other problem, we double check for 11.1a, is number 15. And number 15 is nice because he's one where you guys don't have to make the box and whisker. They already made it for you. You just have to find and think through the data points as far as the median, the first quartile, third quartile, least, and greatest. And just kind of answer the questions like you saw me do. So you have this video, keep watching it to the end. That way you guys can get your Ed Puzzle completion points, which is awesome. And then remember, hop into the online Math Lab hours if you guys want to ask me any questions. I believe 11.3 is going to pop up on Google Classroom at 9 p.m. tonight, along with this video, hopefully. But 11.32 homework, sorry, I was doing a lot of lesson planning today. 11.2 homework is not going to be due until, I believe, Wednesday. So be working on it little bit by little bit and come and ask me questions if you guys have any. Otherwise, I'm going to go ahead and catch you guys later for 11.2b. Yeah.